Hello and welcome back to our work on binary search trees. This is an optional additional lesson about creating a program that makes a binary search tree. And in this example, we'll make a binary search tree using a 2D array, which is something that we've done on paper. This will be some extra work that you can do if you want some stretch and challenge programming activity. However, I will take you through the entire program step by step. In this lesson, we will make a 2D array in Python. Remember, Python doesn't have an array data type, so we will make it as a list of empty strings. We'll start a tree by adding a root node, and then we will append data using the binary search tree rules, and we will also create a procedure that will print out the array so that we can check our work. And I'll suggest some more ideas for work that you can do following on from this. So in this lesson, we're going to make a tree. We're going to input a value and use it to create the root of a tree, and then we're going to add other empty nodes to create an array of a given size. In my example, there'll be a root node and 10 empty nodes, but you can make it as big or little as you want. So in a moment, you're going to write the Python code to make the root node of a tree. When we're storing a binary search tree in a 2D array, what is one node? What would it look like in Python? If you want to write that down, I'm going to put the answer up in a second. So you can stop the program and write something down. Here's the answer. So when we're creating a tree using a 2D array, each node is a list or subarray of 3 items: a data value, which would be input by the user, or I guess you could create one that generates it from random numbers, but a data value and 2 pointers. And when you make a new node, those pointers are obviously both set to none. So can you create a short Python program which creates just a root node on its own as a short list like this? Quite easy to do. Stop this video, open Python and make that. So if you've made that, it would look something like this. The comment says making a tree, but obviously I haven't made a whole tree yet. This is just the root. So I've got a value of the user, the root value for the tree, and I've created a list which is called root, and it has 3 items in it: the value, the data value, and 2 none. Just the word none, which is a Python keyword. It means it's a placeholder, there's nothing there, and that's where I'm going to put the left and right pointers later on. Now I've got to make a 2D array to store the entire tree, starting at the root node and a load of other empty nodes. So I'm going to create a list of lists. That's how I would make a 2D array in Python. The first element is the root node, and then I'm going to use a counter loop, make a lot of other empty nodes and append them to the list of lists, and in that way I will make a 2D array using Python commands. So have a go at that. Stop the video, continue with your Python. I'll show you the answer in a second. So first of all, I've called the tree my tree, and the first my tree is a list, and at the moment the list has got 1 item in it, which is root. Remember, root is itself a list, so I've got a list with another list inside it. Now I'm going to extend that list by adding empty nodes to it like this. I'm adding 10 more empty nodes. I've called it the new node empty, and it's just none, none, none. And I'm appending that empty node to the list 10 times. So now I'll have a list of items that are completely empty. To make things easier, I'm going to also create a procedure called show, which will just print out all the elements of the 2D array so that I can check my work. So you can see the last line of my program uses a procedure called show. So can you write that procedure now? It will print out every element of the 2D array. So here it is. For I in range len tree, print I and tree at position I. So you try that and print it out, and it'll just print out your nice empty 2D array. Now I'm adding some extra lines to my program. I'm going to set the free pointer. Remember, when we're using 2D arrays, we generally have a pointer to tell us where the next free value is, free element that we can add values. I'm getting the user to input a data value, and then I'm calling a procedure which I've called append, which takes 3 values: the tree itself, the 2D array that holds the tree, the value I'm going to add to the tree, and the free pointer, because that tells me where I can add the value. I think last time we did this kind of work, we used free as a global variable, and that will work fine as well, but I just decided this time to send it as a parameter. Our next job is to write that append procedure. If you're feeling confident, feel free to just give it a go right now, which is absolutely fine. I'm going to talk you through it over the next 2 or 3 slides. So you don't have to add the comments as I have. I've done it to block out the structure of the append procedure. So let's just look through this. So the first line of the append procedure obviously declares the procedure and takes 3 parameters: the tree, the value, and the free pointer. Just those are the same parameters we sent from the main program. These are the things we're going to do. We're going to make a new node at the free pointer, and that's what we're going to append to the tree. Then we're going to find the right place to add that new node. So we're going to start at the root of the tree, and we're going to follow the left-right rule outwards, going left if the value is smaller, right if the value is larger. When we find a space for our new node, we're going to change the empty pointer so it points to the new node. I remember that's at the free pointer at the moment. We're going to point to it, and then we're going to update the free pointer. And I haven't added this, but clearly the last thing we're going to do is return to the main program. So let's start replacing those comments with code that does all those different things that the comments say. As always, if I don't remember to say it, just do it anyway. Whenever we get to a point like this, this is a cue for you to pause and try and do it yourself. And there's no problem if you have a go and it doesn't work. There's no problem at all. You've learned something from that experience. Okay, so I'm going to go through this now. So the first thing I'm going to do is make a new node. It's a node of the tree, and it's at the free position. Remember, the free is the free pointer. It's an integer, and it points to an empty location in the 2D array. So in the tree, at that free pointer, add a list with the value and 2 empty pointers. So we've made the new node and we've added it to our tree. We've added it to our 2D array. It isn't hooked onto the tree yet because we haven't added a pointer to it. So we've got to find a place to put our new node. So we're going to start at the root node. We always start at the root node in a tree. And the root node is tree 0. That is the first node in the tree. And I'm just going to call the root node node for now. So our next step is to follow the left-right rule to find where to add a pointer to the new node. Now remember, we're going to go through the nodes of the array one by one. And at every position, node 0 is the data part of the node. Node 1 is the left pointer of the node, and node 2 is the right pointer of the node. So node square bracket 0 does not mean the node at position 0. It means position 0 of the node, the data part of the node. So how do we apply that? See what it looks like. So if the value in the new node is smaller than the data of the root node, then we point to the left, otherwise we point to the right. And now we've got our pointer, we can move on to that node. So whatever the pointer is, we then go to that place. And we can do this on and on throughout the tree, however big the tree is. So I'm going to put the code that I've just added, I'm going to put it inside a while loop. And for now, I'm just going to say while true. That means a loop that goes on forever. Obviously, we're not going to leave it at that. But for now, I've put a loop that will just go on forever. If the value is smaller than the node, go to the left. Otherwise, go to the right. And change the node to be the new value. So by doing this, I will go on and on through a tree of any size, following the left-right rule, changing the pointer and moving to the new node that I'm pointed at. All right, now how are we ever going to stop this? Because there comes a point when we have to stop going through the tree and we've got to find a space for the new node, point to that new node and return to the main program. Our append process is done. At the moment, I haven't got code to do that. When do we know that it's time to stop following the left-right rule and start pointing to the new node? The answer is if the pointer is none. That is, if we find a pointer that doesn't point to anything yet. So let's look at this code. If the value that we're trying to add is smaller than the data value of the node, then we have to hop to the left. Left is node 1. So if the data, the left pointer, is none, then make it point to the free node. That's where we've stored our new value. So make it point to the free pointer and return to the main program. That's the end. That's the end. Otherwise, we change the value of the pointer and we move on in our journey through the tree. And finally, I'm going to fulfill the final thing I've got to do, which is update the free pointer. And the way I'm going to do it, it's not the only way to do it, but the way I'm going to do it is to return the value of the free pointer plus 1 to the main program. So that will update free. Now, the final task for you is to add the code following the word else. So I've shown you the code that will run if the value is smaller than the data at the node. But what if the value isn't smaller? What if it's larger? Or I suppose the same. So fill in all the code that goes below the word else, more or less copy what you can see here on the screen and try and make that work. And then we'll look at what happens in the main program. So in the main program, we set the free pointer to 1, and then we used the append procedure to add a new value, and we returned the revised free pointer 3 plus 1 to the main program, so we have to capture the returned value. So we've now got a main program that adds 1 additional value to the tree using the append procedure. Well, what are the chances that we'll only want to add 1 value to a tree? Pretty slim. So we're going to have to put the whole thing inside a loop. Well, we're going to have to amend this program so that we can add many values to the tree. The only upper limit really is the size of the 2D array. In other words, the length of my tree. So I'm just going to show you how one way to do that. You can try and make that code now, and I'll show you in a second. So this is how I did it, but you don't have to do it the same way. I'm used a while loop while the free pointer is smaller than the length of the array, and I'm adding values, and if the user wants to stop early, they want to break the loop before the array is full, then if they enter a null string, then it will break. The loop will break and it will stop. So that's my finished program now. So make this 2D array program. You might have been doing it as I went through the lesson, or you might like to go back now and follow what I've done, or you might like to try and do it entirely from memory without looking at the lesson. I recommend that as a way of showing that you fully understand it. There is another optional lesson in this series which shows you how to do the same task using object-oriented programming. Again, if you like a challenge, you could try and convert this program that you've just written into an object-oriented program. But in any case, I will show you how to do that in the next one in this series. So, happy programming and see you soon.